Hello dear students, in this hydraulic engineering, today I will continue that open channel flow chapter. So in the last class that we discussed about GVF flow profile, okay, we discussed about mild slope, in detail we discussed, mild slope only. So this PPT, this slide I have showed in the last class that when Y naught is more than YC, it is the slope is called mild slope and flow must be subcritical because depth is more than YC. When flow depth is less than YC, that slope is called steep slope and flow must be supercritical. When it is equal, both are equal, then it's called critical slope. The flow is called critical. Okay. So in between this, by determining this normal depth and the critical depth, the slope is determined. And for even the slope is, there is no slope, okay, bed is horizontal, it cannot sustain uniform flow because discharge will be 0. And also here when slope is negative, that means in case of adverse slope, the discharge cannot be determined if you use Manning's equation. So uniform flow is not sustainable. Okay. So in each slope we classified into different different regions. Region 1, region 2, region 3, region 1, region 3 for steep slope, mild slope, and in critical horizontal and adverse slope there will be 2 regions. Okay, in critical slope there will be region 1, region 3, and here in the horizontal and adverse slope there will be region 2 and region 3. And region 1 that already we will discuss in the last class, that if depth is more than Y naught, which is more than YC, that is considered as M1 profile. When Y is in between this Y naught and YC, it is called M2 profile. When Y is less than YC, which is more than Y naught, which is less than Y naught, it is called M3 profile. Similarly, in the steep slope, it is S1, S2, S3 profile. Critical slope, there will be 2 C1 and C3. Horizontal bed is S2, S3. And adverse slope, there will be A2 and A3. So we discussed that mild slope, and today I'll start from the steep slope. And the steep slope means when the critical depth is more than the normal depth. Okay, the critical depth is normal depth, more than normal depth. Here there is 3 options. The depth, the flow depth at any particular time, it can be more than this critical depth, it can be in between critical depth and the normal depth, it can be less than the normal depth. This critical depth line is this is the critical depth line, and this is the normal depth line. Means the Y can be above CDL, it can be in between CDL and NDL, it can be less than NDL. Okay. So when it is more than above this CDL, it is called S1 flow profile curve. When it is in between, it is called S2. When it is less than or below the NDL, it is called S3 flow profile curve. The first one, S1 flow profile. In S1 flow profile, that already I told in the last class, the velocity here, according to my next question, if you at any for any velocity, for any type of flow, the velocity is 1 by n r to the power 2 by 3 s e to the power half. This is the energy slope. Okay, but for only uniform flow case, the V naught is 1 by n r to the power 2 by 3 s naught to the power half, because in uniform flow s naught is nothing but which is equal to the SE. So here velocity according to continuity equation is indirectly proportional to cross-sectional area and the directly proportional to square root of s. So s can be written as directly proportional to v square. Slope increases, then velocity increases. Okay, so here the y is more than yc, which is more than yn. So if y is more than yc and which is more than y naught, that means if y is more than y naught, then velocity must be less than v naught according to this. Okay, continuity equation. So according to this, the s naught will be less than s naught. Se will be less than s naught. B, this y is corresponding to this SE and y naught is corresponding to S naught. So S naught will be less than SE will be less than S naught. So S naught minus SE, this term in the GVF equation that already derived, that numerator term will be positive because SE is less than S naught. So it will be positive, and since here y is more than yc, it means it is a subcritical flow. Subcritical flow means the Froude number will be less than 1. So 1 minus f square will be more than 0, which will be a positive number. So positive divided by positive, which you will get one positive value. It means if the slope of flow profile slope is positive, it means water depth will increase in the flow direction. So here water depth will increase. So this type of flow profile can be obtained when when a steep channel is meeting a reservoir made by a structure, hydraulic structure, like weir or dam. Like there is a weir or dam and there must be a reservoir. Okay, if there is a steep slope, then the flow profile, what will happen, the flow depth, initially it will be from it will be at a NDL at normal depth, and suddenly here it will jump to become more than YC. Okay, so whenever it means here y will be less than YC, here it will be y will be more than YC. So here it is called S1 flow profile curve from here to here. So whenever the flow is changing from supercritical flow to the subcritical flow, there must be a hydraulic jump. Okay, so try to remember this. Whenever the flow is changing from supercritical flow to the subcritical flow, there must be a hydraulic jump. But in reverse case, when flow is changing from subcritical to supercritical, there will not be any hydraulic jump. Okay, so this is about S1 flow profile curve. Next is S2 flow profile curve. In this flow profile curve, the S or the Y must be in between the CDL and NDL, or less than YC and more than YN. So this is Y naught, okay, YN, that is Y naught, okay. So Y is more than Y naught, okay. It means AC will be less than S naught because B will be less than B naught. So AC will be less than S naught. So this S naught minus ACE, that will be more than 0. That means the numerator of this equation will be positive. And here Y is less than YC, it means a supercritical flow, FR will be more than 1. So this 1 minus F square will be less than 0, which is a negative number. So positive divided by negative, you will get a negative number. So dy dx is negative, it means the water depth will decrease in the flow direction. The water depth will decrease in the flow direction. So this type of S2 flow profile curve can be obtained at the entrance region of a steep channel leading from a reservoir. Here there is a reservoir here, okay, and there is a steep slope. At this entrance from this reservoir, the flow will gradually change from this CDL, okay, to this NDL. So here in this region, from this region to this region, the S2 flow profile can be obtained. So this is about S2 flow profile curve. Next is S3 flow profile curve. Here in S3 flow profile curve, what happened? The Y is here, okay, which is less than NDL. One NDL is less than CDL, below the CDL. So since Y is less than Y naught, it means B will be less than B naught, and AC will be sorry, Y is less than Y naught, it means the B will be more than B naught. It means SE will be more than S naught. That means S naught minus SE will be equal to will be less than 0. See, AC is more, okay, if this is more, then it will be negative value. And since Y is less than YC, so it is a supercritical flow, and F square, this FR is more than 1, so 1 minus F square is less than 0, so its denominator is a negative term, so negative divided by negative is a positive. It means that water depth will increase in the flow direction. So this type of S3 flow profile can be obtained, okay, in below sluice gate with a steep slope on its downstream. If there is a steep slope and there is a sluice gate, okay, flow is coming in below the sluice gate and flowing through this steep slope, then here the S3 type of flow profile can be obtained. And also from a steeper slope to steep slope means less steep slope, from more steep to less steep slope, okay, if the flow is occurring, then the S3 profile also can be obtained here. Okay, this is about S3 flow profile curve. Next is critical slope profile. Critical slope profile means the NDL is coinciding with this CDL, means YC is equal to Y naught. So here two cases only, Y can be more than Y naught or YC, Y can be less than Y naught or YC. Okay, and there is no in between this NDL and CDL, there is no C2 term, C2 profile curve, only one C1 profile and C3 profile. This is 3 profile. Okay, so here the NDL is equal to CDL, so there is no region of 2, there is no region 2. Both C1 and C3 flow are rare. These are very rare and highly unstable condition. Okay, and here the C1 in C1 profile, when Y is more than this Y naught or YC, that means Y naught is equal to YC, which is less than Y. So if Y is more than YC, it means what will happen? Okay, Y is more than this Y naught. Okay, it is Y naught, then B will be less than B naught. It means the SC, okay, will be less than S naught. If SC is less than S naught, then this is, if SC is less, then this value, this numerator will be positive. Okay, and if Y is less than this YC, okay, then it's a, sorry, Y is more than, okay, C1 profile we are discussing, Y is more than YC, then it is a subcritical flow. So F first is less than 1, 1 minus F square will be more than 0. So this denominator will be positive, so positive divided by positive value will give you the positive value. So dy dx is positive, so water depth will increase in the flow direction. Okay, similarly here in C3 curve, when Y is less than Y naught, okay, it means B will be more than B naught. It means BSE will be more than S naught. So SE is more, this term is more, so this numerator will be a negative. And since Y is less than YC, that means flow is supercritical and FR is more than 1, 1 minus F square will be less than 0, so the new denominator will be a negative. So negative divided by negative is a positive value. It means water depth will increase in the flow direction. So in both cases C1 and C3, water depth is increases, okay, in the flow direction. So this are rarely found. Okay, C1, C3 are very rare, highly unstable. Very short period or very short length it may come, but it is very rare. Okay, next is horizontal profile. Okay, in horizontal profile, H0 is 0, means bed slope is 0. If bed slope is 0, then there will be no question of this uniform flow. Because according to my equation, Q is directly proportional to square root of this S0. If S0 is 0, Q will be 0, so there will be no uniform flow. So there is only one CDL, okay, it's critical depth line, or Y, that is the depth is YC. So Y can be more than YC, Y can be less than YC. Okay. So if it is more, it is S2 curve. If it is less than YC, then it's called S3 curve. In case of S2 flow profile, okay, Y is more than YC. Okay, since here this S naught minus SE, okay, this term is 0. So this term will be a negative term. Okay, the numerator will be a negative. And since Y is more than YC, so it is a subcritical flow, or FR will be less than 1, and 1 minus F square is more than 0. That means a positive value in the denominator. So this will be a negative value. dy dx will be negative, so water depth will decrease in the flow direction. Okay. So this can be found in the flow below the sluice gate when it is meeting a horizontal bed. Okay, if flow is coming below the sluice gate and meeting a horizontal bed, so here and this horizontal bed again meeting a drop, sudden drop. Okay, so in this, from this drop to this up to this jump, a S2 flow profile can be obtained. Next is S3 flow profile. In this case, the Y is less than YC. y is less than yc, so it is a supercritical flow. FR will be more than 1 and 1 minus f square will be less than 0, so denominator will be negative, and since here this will be obviously negative because s naught is 0, this is 0, so it will be a negative value numerator, so negative divided by negative will give you positive value, so water depth will increase in the flow direction. Okay, so this can be obtained below the sluice gate if it is meeting a horizontal bed. Just near this sluice gate, there will be S3 curve. Away from this sluice gate, there will be S2 curve. Okay, S3 curve and there will be S2 curve. So here there will be supercritical flow. As I told that when flow is changing from supercritical to subcritical, there must be a hydraulic jump. Okay. So flow is changing here, it is supercritical, which means y is less than yc. Here it is changing y is more than yc, means changing from supercritical to subcritical. So there must be a hydraulic jump. Okay, so this is about S3 flow profile curve. Next is adverse flow profile. Adverse flow profile means the S naught is negative. That means the flow is occurring from a lower elevation to higher elevation in this direction. So if it's negative, then square root cannot be determined. Square root can be determined. So discharge cannot be determined. It means the uniform flow cannot be sustained in this adverse flow profile. Other type of flow profile, other type of flow can be means rapid type can be possible, but uniform flow is not possible in this adverse flow. So here there is no AO1 flow profile, there will be only one CDL, that is YC, and Y can be more than YC, it can be less than YC, but there is no question of AO1 flow profile, there is only AO2 and A3. It is similar to S2 and S3 curves, okay, and A profile curves are very rare and occur very short length. It is very rare, okay, there is no practical situation where this can be shown. Okay, it is very rare and very short length it may happen. Okay, so this is about adverse flow profile. Next, to evaluate the flow profile curve, let's solve this problem. Okay, a rectangular channel, bottom width B is 4 meter, bottom slope S naught is 0.0008, as a discharge of Q, discharge is 1.5 meter cube per second. In a gradual varied flow in this channel, the depth at a certain location is found to be 0.3 meter. At a certain location, it is given 0.3 meter. Okay, assuming n is 0.016, determine the type of GVF profile. So first here we have to calculate the normal depth and critical depth. Then you have to compare both, and we have to obtain whether y naught is more than yc or yc is more than y naught. Okay, then we can see whether slope is steep or mild. Then according to this depth, 0.3 meter depth, we can say whether it is in which region 1, 2, 3 or what. Okay, so here first to calculate this normal depth, we have to use the Manning's equation. So this is the Manning's equation. Q is equal to this 1A into 1 by n, R to the power R is A by P to the power 2 by 3, S naught to the power half. So here area we have to keep in, because we don't know this normal depth. So area is B into Y. So B is 4. So 4 I naught. P is B plus Y, because this is a rectangular channel. So here this is the B. This is the flow. Okay, the flow surface. Here this depth plus this width plus this depth is your weighted perimeter. That means B plus 2Y. 2Y naught, which is 4 plus 2Y naught. So R is A by P, 4Y naught divided by 4 plus 2Y naught. Okay, if we put everything in this equation, this Manning's equation, by using trial and error method, we can calculate the normal depth, which is 0.43 meter. So next calculate the YC. For the rectangular channel, the formula already we have derived, that YC is equal to pi Q square by G to the power 1 by 3. And Q is nothing but the discharge per unit width. The discharge is given, width is given. So now we can put this value here. You can obtain this YC value, that is 0.24 meter. So here the YC is 0.24 and Y naught is 0.43. And 0.43, Y naught is, YC is 0.24. So Y naught is more than YC, so it is a mild slope channel or EM profile, we can say. So here at the particular certain location, at a certain location it is given the y is 0.3 meter. Y is 0.3 meter, which is in between y0 and yc. Okay. So y is in between y0 and yc. It means it is a region 2. That means the flow profile is M2 type. Okay. So like this, the flow profile is evaluated. Thank you. Thank you so much.